What is GABA's relationship to glutamate? So we talked about this yesterday or 2 days ago. We talked about this pretty pretty deeply in the sense of how GABA is created, how glutamate's involved here, and how we actually get GABA from glutamate. So that's a conversion that takes place largely in the pancreas. We'll even get into kind of some type 1 autoimmunity in terms of diabetes and how that plays into things, but let's kind of dive in here. So GABA and glutamate, they act like the on and off switch. They work in opposite ways. GABA is the main inhibitory neurotransmitter in your brain, stopping the chemical messages from passing from nerve cell to nerve cell. Glutamate, on the other hand, is the main excitatory neurotransmitter in your brain, permitting the chemical messengers or messages to be carried from nerve cell to nerve cell. To have properly functioning brain, a delicate balance must be maintained between the inhibitory effects of GABA and the excitatory effects of glutamate. GABA also works with another neurotransmitter, serotonin. In fact, many neurotransmitters work together and against each other and must maintain a certain relationship to achieve and properly functioning a body and brain. GABA is actually made from glutamate. We talked about that a couple days ago on the part 1 sleep, following a reaction with the enzyme glutamic acid decarboxylase. So super cool. Then also remember that, yes, in that previous live on sleep, we talked about GABA and how it is connected to the pancreas, and that in cases of pancreatic insufficiency, this is where the conversion of glutamate to GABA will suffer. So people having a ton of sugar issues and eventually leading to a further problem with the pancreas now being insufficient in some things there. But GABA even being protective to the pancreas, which we also talked about, these things start to go wrong, especially when that glutamic acid decarboxylase antibodies start getting produced. So now we run into some issues there, showing up positive on labs for those antibodies, which you can get tested for. And now, especially when these proteins are created by immune responses, they start destroying the GAD enzyme. So now that is responsible for helping you produce insulin as well. And that's the direct tie here. So the connection with GABA and type 1 diabetes, where this will take place, and now latent autoimmune diabetes in patients starts to develop. So, oh wait, did we get into this? Yes. It's a relationship with glutamate. Pretty cool. And luckily, there are some foods that are very rich in GABA. So, and these I talk about all the freaking time. GABA is present in some fermented foods. Full stop. Pretty much every freaking live that I do and most videos that I do, I am talking about fermented foods every single time. Way overlooked, way underutilized, but beside the point, such as kimchi. I would also throw sauerkraut in here, miso and tempeh. I don't know if I'm saying that right, but also found in green and black tea. And oolong tea, never heard of that. Other foods that contain GABA or boost its production, I hate that word, include brown rice, soy, yucky, adzuki beans, chestnuts, mushrooms, tomatoes, spinach, broccoli, cabbage, cauliflower, Brussels sprouts, sprouted grains, sweet potatoes, and yeah, this is why we're always talking about food groups that you can get these things from. So everything on this list is all good and well, except for the soy. The soy part, I'm not a fan of. Certainly not a fan of. But now for the nerds out there, what the hell are we talking about? So GABA looking like this. This is actually the GABA A receptors. So this GABA B and GABA C receptors are what we are going to be talking about throughout the show here. So yes, that's kind of some background, some anatomy, some glutamate relationship, how the pancreas is involved here, and that those rich foods in GABA, which I encourage people to lean towards. But now, some studies on GABA and L-theanine. Mixing these two decreases sleep latency and improves REM sleep. So throughout these studies, they're they're going to be talking about those two terms, sleep latency and then sleep duration. So sleep latency is pretty much how long it takes to fall asleep, and the sleep duration is how long you're actually sleeping, the total time that you're sleeping. But so looking at GABA, L-theanine versus a control group here, super cool. And your light gray box is GABA alone. So we have GABA alone compared to the darker gray box there is L-theanine, which is an amino acid from green tea. And then we have GABA and L-theanine combined. So the combined group saw improvement in both getting to sleep faster and then total time that it took to fall asleep, or total time that they were asleep. So combining GABA and L-theanine, holy crap. You guys heard me talk about Alcidonia. I don't have the slide here, but Alcidonia, a supplement of ours at the Wellness Way, has both of these things combined for this reason, because it works way better when you combine the two. Um, and also a couple other things in there that we'll get into today too, like passion flower and some B vitamins that are very relaxing. But some more studies here. Um, so now L-theanine, which is found in green tea, as we said before, has been discovered to potentiate GABA, dopamine, and serotonin receptors. Holy freaking crap. To inhibit that glutamate reuptake. So not only that, but it also affects cortisol. And you guys have heard me talk about that before too. So you're now affecting dopamine, you're affecting serotonin, you're affecting GABA levels, and cortisol. My goodness. Why people are not drinking more green tea, I don't know. But the matcha girls that are running the show there are probably pumping their fists in the air like crazy. And L-theanine as a whole is very affordable, very affordable. So people that are having some issues with cortisol and some of those other neurotransmitters, you can affect them all by just doing one little thing, and it's damn near affordable to everybody. So, but here we go, the aqueous root extract, and now we're talking, when you see aqueous root extract there, we're talking about ashwagandha, of Indian ginseng, and then big fancy word there, has been shown to act and be a potent agonist of the GABA C receptor. And not many things are having effects on GABA C receptors. But so not only the GABA C is being affected, but also the GABA A receptor. So kind of crazy. And ashwagandha, oh my goodness, we're lagging out here. There we go. We're back. Ashwagandha is one of my personal favorites because it's more of an adaptogen, so it's not going to make you like super tired and then you have to go to bed kind of a thing. It's more of a happy medium. So it's kind of like giving a hug to the adrenal glands there. But let's keep going here. And again, Indian ginseng, also known as ashwagandha, we're not only affecting the GABA A receptors, but GABA C, and obviously reducing sleep latency, so you get to bed quicker and you improve sleep quality. So holy crap. Now we got something that we're already getting into a couple things here. We got L-theanine having an effect on several different neurotransmitters and cortisol there. Ashwagandha will affect cortisol as well, but still showing benefit to doing sleep. But you can't just go out and take every single one of these things. It's easier to kind of dial in and see what's best for you. But another one, and this one many of my patients know very well of, California poppy. So this guy, behavioral effects of the American traditional plant. This is the state flower of California, California poppy. And then we got another study here, alkaloids in commercial preparations of California poppy, quantification in intestinal permeability, and microbiota interactions. So we're going to get into how neurologically California poppy impacts the body, but also how it impacts the GI. And then through that, how it's affecting 5-HTP, how it's affecting serotonin, and then eventually from serotonin, you convert into melatonin. So let's get into some of that too. Pretty hefty here. Let's go. I'm just going to read the first paragraph. So, phytomedicines containing California poppy, big words, are widely used for the treatment of nervousness, anxiety, and sleep disorders. Reported pharmacological activities include modulation of the GABA receptor activity, serotonin receptor binding, and modulation of catecholamine metabolism. I talked about kava in the previous live too, and how kava helps you get rid of a lot of those catecholamines. Kava's definitely taken the crown on that action step there, but California poppy also has effects on here too. But let's keep rolling. Um, where were we? Okay, the sedative, anxiolytic, and analgesic effects. So very calming, um, kind of putting you on the couch, reducing that anxiety. But the analgesic properties too, helping with pain. Present in the plant include, and then a bunch of fancy words. Most abundant followed by another fancy word.